Invading algae. Biological invasions by exotic species are an escalating threat to biodiversity around the globe. Invasive species can displace native ones and irrevocably alter ecosystems. Most imported species either die or have limited growth in their new home, but a small percentage of the newcomers are opportunists whose growth is dangerously out of control. The story of how Caulerpa taxifolia became famous as one of these species began in 1989 when Dr. Alexandre Maynes, a marine biologist at the University of Nice in France, learned that this exotic alga, which is native to the Caribbean and other tropical seas, was thriving in the Mediterranean waters off the coast of Monaco. Upon investigation, Maynes discovered that a mutant variety of C. taxifolia was dumped into the Mediterranean with other aquarium refuse by the prestigious Oceanographic Institute of Monaco. Eventually, the C. taxifolia was traced back to a stock developed at the Wilhelma Zoological and Botanical Gardens in Stuttgart, Germany. This stock of C. taxifolia had caught the attention of amateur and professional aquarists for its exceptional beauty and hardiness, and had been widely distributed in public and private aquaria in the 1980s. Instead of dying in the cold winter waters of the Mediterranean Sea, as the tropical variety of C. taxifolia does, the mutant variety can withstand several months at temperatures that range between 10 degrees and 13 degrees Celsius. In addition, the alga grows equally well on a variety of ocean substrates, sand, mud, or rocks, and from near the surface to depths of 50 meters. When temperatures exceed 18 degrees Celsius, the mutant Caulerpa grows at a remarkable rate, capable of elongating by 2 centimeters in a single day and forming a new frond every 2 days. A single square meter of seafloor can be matted with 5,500 leafy fronds. All of this growth is asexual. Unlike the tropical form, the mutated form of C. taxifolia produces only male gametes in the Mediterranean and thus replicates only by fragmentation. Just a small piece can regenerate and colonize an area. In fact, it is believed that fishing nets and boat anchors, as well as the ripping action of storms, have helped the alga spread to new areas. With such a rapid rate of growth, the Mediterranean Caulerpa grows quickly over the sea bottom, blanketing all other sea life such as marine angiosperms, native algae, corals, and sea fans. It cuts off vital essentials such as sunlight for photosynthesis and currents for filter feeding of nutrients. The area becomes a Caulerpa lawn while species diversity is lost. In addition, C. taxifolia is inedible to most marine herbivores because of the presence of toxic compounds, primarily caulerpinine. With no predator to inhibit its phenomenal growth, the alga had encompassed the Mediterranean coasts of Monaco, France, Italy, Spain, and the Croatian coast on the Adriatic Sea, covering 30,000 hectares by 2002. Caulerpa infestations have also been found in southern Australia, in estuaries near Sydney and Adelaide. Various methods have been tried to eradicate this deadly invader. Divers have been employed to rip the alga out by hand, but care must be taken because even a small fragment is capable of colonizing new areas. Black plastic tarps have been placed over the alga in an attempt to deprive it of life-giving sunlight. Chemicals such as copper, a conventional algicide, and toxic levels of salt have also been applied to Caulerpa fields. There has been limited success, but only if the area of invasion is small. One hopeful avenue is biological control. In biological control, a disease or predator of the invasive organism is introduced and allowed to destroy it. In the native range of the tropical C. taxifolia, 2 species of sea slug are immune to its poisons and feed on the alga exclusively. They suck the cytoplasm out of the leaves and incorporate the algal chloroplasts, the part of the plant that contains green photocytic pigment, into their skin. The chloroplasts provide camouflage as the snails feed in the Caulerpa fields and, surprisingly, continue to photosynthesize, providing additional nutrition for the slugs. Dr. Maynes is suggesting the importation of these slugs to the Mediterranean as the only way to eliminate the immense area that Caulerpa now covers. But many experts fear that another exotic importation may lead to more environmental damage.